Hello students, welcome to continuity of the function. In last video, you learned that how to find the values of k if the function is continuous. In this video, I am going to discuss properties of continuity. First, let me discuss algebra of continuous function. Algebra means addition, subtraction, product and division of two functions. What happens if f and g are any two functions? Addition function, what happens? Subtraction function, division, product, these functions whether continuous or not, that you are going to learn. Okay, so first let me show you the properties. If f and g are two continuous functions, then remember students, f plus g is continuous function, which means if you add any two continuous function at any point, then if you add that two functions, the resultant addition function, that is also a continuous function. Second one, f minus g continuous, that is subtraction. If you do any subtraction of two continuous functions, that also continuous function. Third one, product. And fourth one, division, that is f upon g is also continuous, but condition for division is g should not be 0. That means for which number or which set of numbers that is function, g function is becoming 0, except that numbers f upon g is become a continuous. Okay, so now let me prove these identities or properties one by one. First one, addition. So now we have to prove that addition function at any point and limit as x tending to that point, both should be equal, because according to continuity, if any point is there, f of that and limit as x tends to that point, it should be equal. Now here the function is f plus g function. We have to prove it for all the real numbers. Therefore, consider one general point a. A is a general point, every number, every point, okay, general point it is. Now f plus g of a, what we get, it is addition of two functions properties. We can write this as a f of a plus g of a. Okay, next we have to find out limit now. Limit as x tending to a point of addition function. Okay, so now this is written as, using the properties of limit, limit as x tends to a, this is written as f of x plus g of x. Okay, now limit as x tends to a, f of x is continuous. What is the limit of f of x become? It become f of a, because f of x is given that continuous. Therefore, limit as x tending to any point, it should be equal to f of a. Similarly, limit as x tends to a, g function, it is also g of a. So therefore, here using properties of limit, if you write limit as f of x, x tends to a, and plus limit of x tends to a, g of x, then it can be written as f of a plus g of a. Okay, taking limit separately and then using the properties of continuous, limit as x tends to a, f of x, it is written as f of a, and similarly limit as x tends to a, g of x is equal to g of a. So it become f of a plus g of a. So which is same as f plus g of a value. It implies that limit of f plus g of x and f plus g of a both are same number, f of a plus g of a. Therefore, what we can say, f plus g is a continuous at x equal to a, and a is a general point. Therefore, we can say that f plus g is continuous for all the number, or simply f plus g is continuous. In the same manner, we can prove that minus subtraction. Okay, now see the proof for subtraction. Same way, consider one general point a and find the value. So this value is written as f of a minus g of a, and then limit as x tends to a, f minus g of x, limit as x tends to a, f of x minus g of x. So now as x tending to a, f of x, limit is written as f of a and minus is written as g of a, and this is same as f minus g of a value. So therefore, what we can say, the function f minus g is continuous at x equal to a. I hope you understood this derivation, and in the same way the product and division or other two are follows. Now let's go to examples. First question, discuss the continuity of sine function. Here I am discussing the trigonometric functions, whether they are continuous or not, if they are discontinuous at which point. So I am going to discuss this one. We know that there are 6 trigonometric functions, so one by one I discuss, and you have to remember all these results, whether sine function continuous or not. These are very useful in future, and you should know it, whether it is continuous or not, discontinuous, or every number or particular number, everything you have to remember here. So here we have to discuss continuity of the sine function, not at particular real number or radian angle. It is given general, which means that for all the numbers, for all the angles, means minus infinity to infinity. Here minus infinity to infinity real number, which is same as equal to radian angle only. Okay, now first one, as you know that to check the continuity we have to check it for general point. Let C be any real number, that is arbitrary point. Arbitrary means general, any one general point. Then f of c is equal to, it becomes sin c. Next, limit as x tends to c of the function, that is sin x function. It is also same, sin c. So therefore, what we can say here, f of c is equal to limit as x tends to c, f of x, it is equal. This implies sin x is continuous at c, and c is an arbitrary point. So it follows that sin x is continuous everywhere or for all the points. So remember students, now onwards, sin x function or sin theta, whatever variable you can take, anyone, theta, alpha, x, totally sine function always continuous for all the number. So now next go to second example, it is cosine function. Discuss the continuity of the cosine function. So here also same, point is not mentioned, which means from minus infinity to infinity. Okay, so first take one arbitrary point, CB, any arbitrary point, any real number. Then first find f of c, it is cos c term, and then limit as x tends to c, f of x is equal to limit as x tends to x tends to c cos x, it is also cos c. Now both are equal, so therefore f of c is equal to limit as x tends to c f of c, sorry, f of x. This implies cos x is continuous at x equal to c, and c is arbitrary. It follows that cos x is continuous. Okay, next function is a tangent function. Discuss the continuity of tangent function. Here also point is not mentioned. So minus infinity to plus infinity. So first solution. Here just I am recalling the properties, because the tangent function continuity we can discuss using this property: addition, subtraction, f upon g, f into g. So just remember these properties. Algebra of continuity of two functions. Okay, so what is a f of x here? Tan x. Tangent function I am writing as a tan x. F of x is equal to tan x, but tan x is written as sin x upon cos x. So just now you learned that sin x and cos x are continuous. Now by the algebra of continuity of the function, the ratio of sin x and cos x is continuous everywhere, but cos x function should not be 0. Therefore here we take cos x equal to 0. We are finding for what values of x it becomes 0, for what angle it becomes 0, that we have to write. So therefore I take here cos x equal to 0, and I write the angle here, so that you know that in first year you studied in general solution cos x equal to 0 equation. Then solution for this equation is 2n plus 1 into pi by 2. So which means that the tangent function is continuous except these angles, odd number pi by 2. That means tan x is discontinuous at pi by 2 angle, 3 pi by 2 angle, 5 pi by 2 angle, 7 pi by 2 angle, and so on, which means odd number of pi by 2. The tangent is discontinuous. Tangent function is discontinuous at odd number pi by 2 and continuous for all angle except these. Okay, so next similarly cot function, that is cotangent, we say. Discuss the continuity of cotangent function. Discuss continuity of cotangent function. These are the properties. Now consider the function f of x is equal to cot x, and this function written as cos x divided by sin x. Okay, here denominator is sin x. So therefore sin x and cos x are continuous for all the numbers, but whenever we take ratio we have to check that for which angle it become a 0. The sin x function is become 0. So therefore what we write here is continuous everywhere, but sin x equal to 0 except where sin x equal to 0. Okay, now writing the solution for this equation, what we get x angle, it is n pi. So therefore what we say here, cotangent function is continuous except x equal to n pi, which means other than n pi angle, for remaining angles cotangent function or cot x function is continuous. Okay, so next move to next function, that is second function. So now second function is written as one upon cos x, and 1 is constant function. As you know that every constant function is continuous, and cos x is also continuous, but the ratio using the property, what we can say, 1 upon cos x, that is also continuous, but except cos x function is 0 number. Okay, now what we have to find out, which x angle this cos x becomes 0 value, that is solution. So now this cos x becomes 0 for odd number pi by 2. So therefore what we can say here, the second function is continuous except 2n plus 1 into pi by 2 angle. For remaining angle, if you draw the graph is continuous, that is function is continuous. Okay, so next move to next example, that is a cosecant function. It is also same way. First we consider f of x as cosecant x, and it is written as 1 upon sin x. Since 1 and sin x are continuous function, what we can say by property, 1 upon sin x is continuous, but sin x function should not be 0, therefore except when sin x is 0. So when sin x 0 become, x angle is n pi. So that means cosecant function is continuous except x equal to n pi. Other than these angles, remaining angles, the function is continuous. I am clearly saying that the cosecant function is continuous other than this n pi angle. Okay, now using these knowledge, that is sine function, cos function, okay, and tangent, where when for which point it is continuous, which is not, for which point it is not continuous. So with the help of this and properties of continuity, now I solve any type of example. Now let me solve now different examples. These are the standard examples, remember, trigonometric ratios. Next is different examples. Now I use this knowledge to examples. Discuss the continuity of the function f of x is equal to sin x plus cos x. Very simple example. It is a addition of sin and cos, that is sin x plus cos x is entire is now one function. Okay, the solution is, now here we are not using any general point, and I am not finding limit and general point value, just I use the property and I write the solution. See here, let f of x is equal to sin x plus, sorry, f of x is taken as sin x and g of x is equal to cos x. Okay, now as you know that sin x is continuous and cos x is also continuous, what we can say, addition function f of x plus sin x, f of x plus g of x, that is sin x plus cos x is also continuous. So remember, similarly sin x minus cos x and sin x into cos x are also continuous function. Okay, now let's go to another question. Examine the continuity of f where f is defined by f of x is equal to sin x minus cos x, x is not equal to 0, and minus 1 if x equal to 0. Okay, now here in this example, the point is not mentioned, like particularly at x equal to 1, x equal to 5, x equal to 3, it is general. Now first see the condition x is not equal to 0, which means that sin x minus cos x, this function is used or defined if x less than 0 and greater than 0. For both it is a same function, and equal to 0 point the function is minus 1. Okay, now first observe that if x is not equal to 0 means sin x minus cos x function is defined, and just now I discussed subtraction of two sine functions, sine and cos function, it is also continuous. Therefore it is continuous function for lesser than 0 and greater than 0, because it is a subtraction of sin x and cos x. Sine is also continuous, cos is also continuous, therefore subtraction is also continuous. Therefore other than 0 number function is continuous. Now what about 0 point? Now here 0 point it is a splitted, so we cannot say exactly taking 0 value it is defined minus 1 the function is continuous. We should not do like that. Now we have to find out continuity at 0 point, and at exactly 0 point the function is splitted. Therefore LHL and RHL, or limit of the function, we have to find out. Limit at x equal to 0 f of 0 is become minus 1, and limit as x tends to 0 it is also minus 1, and then we say that both are equal. Therefore f of x is continuous at x equal to 0. So from this what we can say, function is continuous at every point. But in this example we discussed only when it is less than 0, greater than 0, it is continuous using the property, but exactly 0 point the function is splitted at 0. Therefore we have to write f of 0 and limit of the function. Now 0 point it is continuous, less than 0, greater than 0 also it is continuous because using the property. So therefore what we can say, function is continuous for all number. Thank you students.